So absolute value functions, we did absolute value equations. Do you remember absolute value equations? We did those in chapter 1. Don't forget those. Go back, review them. Maybe if we have time, we can review a little bit today. Don't forget them. Remember that all your tests are going to have previous material on them. So your chapter 2 test will have chapter 1 material on it. Hint, hint, nudge, nudge. Okay.
Wait, so does it mean chapter 3 will have chapter 2 and 1, or just chapter 2?
So wait, so at the end of the year, you're gonna have like from chapter 1 all the way to chapter like 20?
That's what math does. Did you stop solving equations from pre-algebra when we were in algebra 2?
Yeah.
No, you didn't. You're still doing them. They're just harder. Alright,
I forgot
so
about
an absolute value graph. Remember we talked about what absolute value means. It's the distance that is from 0. But numerically, you're just taking the positive version of the number. So the absolute value of 5 is 5. The absolute value of -5 is also 5, because distance is always positive. Now, an absolute value function is really just like a piecewise function, but like a piece here and a piece here. So this function could be written as a piecewise function. If this says absolute value of x, you're looking at 2 pieces. You're looking at the positive and the negative piece. Okay. This piece is going to be for all values greater than 0, and this value, or these values, are going to be less than 0. One of them is including, one of them is not including. Doesn't really matter. And so what that looks like, the positive piece goes through the origin and has a slope of 1 and exists for all values greater than 0. If you're looking at it with a table, it's an old-fashioned way. When you plug in 0, the absolute value of 0 is 0. So you have a point at 0, 0. When you plug in 1, the absolute value of 1 is 1. So you have a point at 1, 1, 2, 2, 3, 3, etc. Now the other part of this is the negative side. If you plug in -1, what do you get?
You get 1.
You get 1. So you plug in -1, you get +1.
Oh.
This side is still a line. It has a -1 slope. Okay? It's still direct variation, so it goes through the origin, but it's got the opposite slope. So it's perfectly symmetric with the blue side. Whoops. And it just has the negative slope instead of the positive slope. So what shape does that make?
Triangle.
Parabola.
Sure. I say it's like a V. It's not parabola because parabolas are curved at the bottom.
Oh, it's like
This is pointy.
A pencil.
Oh yeah,
A
now I remember
cone.
what absolute values are.
a cone.
So absolute value functions look like either this way or this way. So a V or like upside down V. The point right here, the point where the slope changes from a negative slope to a positive slope is called the vertex. Throughout Algebra 2 and probably beyond, we refer to the vertex as a point H, comma K. H is the x coordinate of the vertex. K is the y coordinate of the vertex.
Oh my
Okay, and we'll use that over and over again, so don't forget. H comes before K in the alphabet, X comes before Y in the alphabet, so you don't mix them up, H and then K. What we'll do moving forward is we're going to identify the vertex of the absolute value function, and then we'll figure out the slope, because it's basically linear. It's just double linear. It's basically like graphing a line, but you're starting with a vertex instead of a y-intercept, and then you're graph two slopes that are opposite each other instead of just one slope. Okay, so with lines, we graph the intercept and the slope typically. We're gonna graph a vertex and two slopes and make sure that it is symmetric and it means. That's what we're gonna do. Do you see this up here?
Yeah.
This is like the general form, the naked version of the
Oh.
parent function. We can use that format to figure out the vertex and the slope. So anything subtracted from x. So subtracted from x is going to be the x coordinate of the vertex. So if there's a number next to the x, that's the x coordinate of the vertex. If there is a constant added on at the end after the absolute value,
So why?
that's the y. And then the a at the beginning is
Slope.
the slope.
Whoa.
Now, it's kind of like a slope. We do two slopes. So I call it a slope with quotation marks because it's like two slopes, you know, we have to reflect it. But it's basically your slope. Now, in the future, we will refer to h and k as just more than just the vertex. Okay? The vertex here was what?
And 0, 0.
At 0, 0. This is called the parent function, right? The parent function is the most basic version of a function. Like, super basic, standard. There's no vertical or horizontal translations. It's not stretched in any way. It's just the most basic version that you can get. So the parent function has a vertex of 0, 0, and the slopes are 1 and negative 1. Anything else that we graph is going to be some sort of alteration of that. So it might be moved up, down, left, right.
Oh.
It might be stretched to be wider. It might be smushed to be skinnier. The y coordinate of the vertex is a type of vertical translation. Write this down. If k is 5, you vertically translated the whole v up 5. If k is negative 5, you translated the whole v down 5. So it's vertically, it's moving it vertically.
So like on the test, when we have that, we're gonna have to like identify what kind of like
Yep,
thing it is, and then say how much it's translated.
yep.
Oh.
Now the h, since it's next to x, which way do you think it moves it?
Down.
Left,
Horizontal.
right.
We just moved it down. It's going to be
Oh.
horizontal.
Horizontal.
So the h is a type of horizontal
Right.
translation. Okay, so if you have something either added or subtracted to x in the absolute value, that's going to move it either left or right. Minus moves it to the right,
Wait, minus moves it to the
plus moves it to the left.
And then
Why?
X.
Minus moves it to the right. Write it down if you have to. Plus moves it to the
But
left.
why?
Am I pointing in the right direction for you?
No.
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 I'm pointing to my left.
Yeah.
Your left is that way.
Wait, so
Yeah.
Alright, so plus
Minus.
moves it to the left.
Uh-huh.
Minus moves it to the right.
Thank you.
No.
Wait,
Wait, yeah.
no.
Because
That's still
Am I
the
still
exact
pointing
same. It's still
yeah,
the exact same
this way's
thing.
left.
Uh-huh.
no.
I know that it's backwards. That's
Oh.
what the rule is.
Plus
Plus moves it to the left, minus moves it to the right.
What?
Because the general form of the equation is x minus h. H is the horizontal translation. So if it says x minus 2, 2 is the horizontal translation, meaning it's moving it to the right, positive 2.
Oh, because it's absolute value.
No, that's not why. If it says x plus 2, that's like x minus h. H would be negative 2, meaning you'd go to the left 2. The form of the equation is x minus h. H is the translation. So if it says x minus 2, 2 is the translation, not negative 2. What is subtracted from x is the h. So if it says plus, what's subtracted from x is a negative 2. That moves it to the left. Okay.
Man, this is confusing.
And then finally you got A, which is the slope. If the slope is greater than 1, like 2, 3, 1.7.
Ms. Rep, I got one quick question.
I got black. I got one.
Wait, why is it opposite?
I'll get there. Again, I'll explain it again in a different way, but hold on. If A is greater than 1, then it's going to be a steeper slope, which means it's going to go like this,
Okay.
right? So it's going to squish a little bit. So we call that a vertical
Vertical.
stretch,
Do you have to do the domain and range?
or you might see it as a horizontal compression. So it's like compressing it vertically, or it's like stretching it vertically.
Oh, you know, like,
So we use the words vertical to stay consistent. So it's like a vertical stretch when it gets skinnier. So skinnier. If A is a fraction, like 1/2, 1/3, 2/5, so a fraction between 0 and 1, that's a vertical compression.
What does that do?
It makes it fatter
But is
because
it
the
compression
slope will
pushing
be
it?
less steep. So it's gonna be like wider, more open. So it's like if you took the V and like smushed it like this, it's like compressing it, making it fatter. Does that make sense? Okay, pay attention. I'm only gonna explain this once and I'm never explaining it again for the rest of the year.
Michael.
If this is a function,
yep.
and we're trying to figure out the x-intercept. The x-intercept is the value for x when y is 0. So we plug y in. How do we solve an absolute value equation? Okay, so we're supposed to take what's in here, we set it equal to 1 positive, we set it equal to 1 negative. Well, there's no such thing as positive and negative 0, so we basically just do this. Okay, then we solve. We add 2, we get x equals 2.
For both.
The x-intercept is 2. That's why it moves to the right. At the left. Because when you solve it, it
you
goes
solve
to
it.
2, not negative 2. Because our rules for equations wind up switching things. Y doesn't do that. Because y, you have like a plus 3, right? If we're trying to find the y-intercept, plug 0 in. Does it undo that 3 and make it negative?
No.
No, you just add 3.
5.
But it's just going up, like it doesn't change it. You just add 3, or you subtract 3. So the y translations don't change that way. Okay, it says plus k, it says plus 5, you go up. Minus 5, you go down. But with the x's, they're backwards. So just remember they're backwards. Now, this was our parent function. Let's talk about domain and range. In the past, we've mostly just done like lines. So we don't really have to worry about that because the domain range of a line is all real numbers and boring. The domain and range for this is not going to be, or are not going to be, all real numbers for both. Domain is your set of your x values. There isn't an x value that I can't plug in here. I can plug in whatever I want. I can plug in 2, plug in 200, I can plug in 1,000, negative 1,000, whatever. I can plug in whatever I want. This graph keeps going to the right and it keeps going to the left forever. Yes?
Yeah.
When it keeps going to the right and it keeps going to the left forever, that means your domain is everything. X can be anything it wants. So we write that a few ways. One way is using interval notation. Okay, so this is interval notation. This should look familiar from chapter 1. And then the other way is using set builder notation. Okay, if x belongs to the set of all real numbers, put a little squiggly bracket. You're gonna say, what variable am I talking about? Oh, I'm talking about x.
ER.
Define x. Can you not?
Is that you?
No.
Oh.
I'm like literally in the process of explaining it and you're being obnoxious. So
Sorry.
just wait. So, squiggly bracket, you put the x. we're talking about x. If you're talking about y, you put the y. Put a vertical line here. This says x is such that. Basically fancy talk for x is gonna be what I'm about to tell you. And then you put x is all real numbers. You could literally write the words x is or x belongs to the set of all real numbers. Instead, this symbol, which is not an e, it is what it looks like, means to belong to a set. This is the symbol for the set of real numbers.
How do you
Which
write
is an
that?
R with an extra line through it. I don't know,
Oh.
try it. So this is the symbol for real numbers. Remember I showed you there were other symbols, right? We had integers, we had whole numbers, and they all just looked like whole numbers, just looked like a W with like an extra line in it. So we go like this. Okay, real numbers is an R with an extra line in it. So this is representing a set of real numbers. And X is in it. All of them. He's all the real numbers. It could be any of them. He's not limited to maybe just the positive ones or just the negative ones. It can be all of them. This is called set builder notation. And this is called interval notation. We need to know both. Like I said before, you could also just write the words x belongs to the set of real numbers, or x is all real numbers. Write the words out, but this is shorter. So x is everything. Graph goes to the right, graph goes to the left, x is everything. Y is not everything. I'm gonna erase this a little bit. Just this. Looking at the graph, how far up is the graph going to go?
Really far.
Really, really far.
Really
About 10.
Unlimited far, right?
Unlimited.
About 10. That's where the graph stops.
Yeah, that's right.
It keeps going, right? How far down does it go?
Five.
It does just
Wait, it doesn't. Wait, it doesn't go.
It
Doesn't
goes
matter.
to the origin. Okay, so think y. What is y at the origin?
0.
0. Why does it not pass 0?
Because that's the origin.
What kind of function is this?
It's absolute value.
It's absolute value function. It can't be negative. So it's not passing 0 because y can't be negative because it's absolute value. So that's why we're not including any of these values. Now that doesn't mean that other absolute values can't go down there. If there's a vertical translation, they'll go down there because we'll scoot them down there. But if there's no vertical translation, which there's not, we can't include these numbers here. There's two ways to write that. In interval notation, y starts at 0 and then it gets bigger. Right? In set builder notation, now we're talking about y. So we do squiggly bracket y. And what's y doing? Y is getting
Why?
bigger than
Why?
0.
Oh.
Y is greater than or equal to 0 is what you would put after the vertical line because it's getting bigger than 0.
Is that for
We're also including 0, right? 0 was a point on our graph, so we need to include it. So we put or equal to and we put the closed bracket.
0 bigger than 0?
Questions? No? Are you sure?
Who knows question?
This is the parent function. So all of our other functions, they're gonna have the same general shape. They might be skinnier, they might be wider, they might move around. So they might be like over here or like over here. They might be wide, they might be skinny. The domain and range will change as you start moving it around. If we move it all the way down here, it's not gonna be 0 to infinity anymore. It might be 0 to 7 million, jillion, I don't know, depends. It can also go upside down. Okay, so those are a little bit later. So I'm gonna wait on those. So before we start going upside down. So let's look at the next example, which is not the parent function, more detailed here. In the absolute value lines, you have x plus 1. This is going to horizontally translate it to the left 1, which means that the x coordinate of your vertex is -1.
-1.
Yeah.
Oh, it's a sad face.
Look at the guy.
Okay, and then the -2, see how -2 is not in,
Bracket.
it's not in the absolute value bracket, so it's off to the side. That means it's a type of vertical translation. It's gonna move it down 2. That means the vertex is at -2,
Illegal.
right? If it's down 2, it's down there at -2.
Wait, so is the vertex at -2, what? -2, 0, or -2? Oh wait, -1, -2, or 0, -2.
What?
X, Y. Vertical comes second, horizontal comes first. So -1, -2. Alright, so we're gonna graph our vertex first. Always graph the vertex first. Don't graph other stuff first. It makes it more difficult. So our vertex is at -1, -2. This is our vertex. I'm just labeling it so we remember that it's the vertex and not just like something random. You don't have to do that if you don't want to.
It's -1 because it's 1 minus 2, right? And you like do the.
No, it's -1 because it has a horizontal translation up to the left one.
Yeah. I'll not explain that.
Okay, now we'll graph the rest of the shape, which we know is gonna look like a V. Could look like an upside down V, but not yet. We're just gonna do positive ones. So it's gonna look like a V, we're gonna find the slope. The slope's gonna be right here. Do you see anything there?
It's
1
1
over
over
1.
1.
Yeah, so if you don't see anything, it's 1.
See something.
So our slope, in quotation marks, because it's not really a slope, is 1 over 1, but we have to do 2 slopes. So what we're gonna do is we're gonna go up 1 and then right 1. We're also gonna go up 1, left 1 from the vertex.
Is that because it's absolute value?
So from my vertex, I'm gonna go up 1 into the right 1, and I'm gonna put a point there, just like I would for any line. Then I'm gonna reflect it on the other side. So I'm gonna go back to my vertex. I'm gonna go up 1 to the left 1. And it should look like a little like mouse face.
You made it.
See like his little nose? And then you're just gonna
Okay.
connect, so you're done. You need 3 points to graph an absolute value function instead of 2 like a line.
You only
This is
need
like
3?
2 lines that share that vertex.
Whoops.
So this part goes like this, and this part goes like this. Ta-da! So pretty.
Let's go.
No key, I'm like slowly dying.
I don't understand what you're saying, but
Here we go.
let's go. Shake.
Moscow.
Okay, and then it wants us to identify the domain and the range. Domain. How far does it go to the right?
Infinite.
1.
How far does it go to the left?
Oh, infinite.
Okay, so the domain has all real numbers.
Yep.
2 ways to write that.
Range is a
Interval notation, okay, or set builder notation.
Does it include infinity?
Hmm?
Does it
You
include
can't include infinity. Infinity's not a number.
It's real.
Okay, range. The range is different now.
-2 and infinity.
What's the smallest number that the y can be?
-2.
And what tells you that?
The number.
The vertex. So hint, hint, nudge, nudge. The range is always going to have something to do with the vertex. Okay, so look at the y value of your vertex, and that's either going to be the minimum or the maximum. In our case, it's the minimum. Whoops.
Minimum sentencing.
Sure, mine
Okay, and
was
we're
so
always
long.
including it for absolute value. Okay, so my weird infinity sign, I apologize. And then in
What
set
is it?
builder, we're saying greater than or equal to -2.
You have to write both always.
No, we're just writing both for now, so we can practice both. I'll specify. Yeah, I'll say set builder or interval. I mean, I might say both, but you guys are more comfortable with interval notation because we already did it.
Yeah.
Wait, how do you draw
Say
that?
so
Like,
myself.
how do you draw that? Like bracket?
Different because what?
It goes up.
This one goes up.
People who.
Wait, no, wait.
Yeah.
Yes,
Well,
it
yeah,
does.
it like goes up forward.
And
What
then
else?
it
Oh,
has, it has a negative
so
slope.
the x is in the absolute value.
It has
Wait,
a
no.
negative slope.
There's a negative slope. So I don't know if you guys remember like parabolas
Then it's
forever
gonna go like
ago,
this.
but we did like happy face, sad face.
Yeah.
If the slope is positive, goes up towards the positive y's. If the slope is negative, it goes down. So this v goes down. It's a sad face.
Oh,
He's upset.
Because he's negative. Negative Nancy.
50,000
Down.
on my head.
Now, the other thing that's different though is that there's nothing inside the absolute value, right? It's just x.
I'm upset.
So when there's nothing inside, that's fine. That just means that the x coordinate of the vertex is 0. It means that there was no horizontal translation. There is a vertical translation up 4.
Okay.
So
Imagine you just say,
right here. So 0, 4 is our vertex. The rest of this is going to go down. So you're still going to use the slope the same way. You're just going to make it go down instead of up.
So they go
So if the slope's -2,
1, 2, oh,
down
1,
2,
Oh,
to the right 1,
yes.
okay? Go back,
to the opposite.
down 2, to the left 1.
Yep.
So
To the
down
left, to the
2
left.
and to the right 1,
Negative
down
Nancy.
2 and to the left 1. And that's your graph.
Parabola.
Not parabola, it's absolute value.
Oh.
But with
Oh,
parabolas,
man.
it was like the same rule, negative sad, positive
Positive
happy. The same idea.
Negative.
Negative y's go
Wait,
down,
so does the
positive y's
range go
up.
down now?
Yeah, so let's see. Has the domain changed?
No.
No.
Still no.
It's still the same.
Still the same.
Negative 1, 1.
Okay, domain has not changed.
Also, I can write it however I want. So like I can choose that one.
No, you should be practicing both.
Alright, I'll do both then.
I think it's fine.
Practice both.
Wait, so is it like you're gonna do an R but you don't finish this part and then you start an R again?
Yeah. Like this, and then you just,
We. I guess you're right.
or you could make the R and then add an extra one in there, I guess.
But that's
Anyhow,
Ow.
the range is changing now. James. The range is changing now because the highest value is not infinity. What is the largest value x can be or y can be?
4.
4.
Fall.
That goes over here for interval notation.
Would say.
Then it's going to be as small as,
Negative infinity.
Negative.
yeah, as small as it wants.
So you just flipped it. So if it's negative, you flip the 2, basically.
Oh.
Always put the smaller boundary on the left, upper limit on the right. Small, big.
So hard to draw an 8-sided.
Oh wait. So wait for the what's it called? A
Set
set.
builder.
So set builder. Would I flip the? Would it make it
It would
like
be
less
larger.
than or greater than?
No, it'd be
I mean, less than or
larger
equal
or
to.
equal to. Wait, what?
You flip the sign.
So it's gonna be y is less than or equal to 4. Gotcha.
I get it. I get
Yeah,
it.
I get it. Wait, wait.
Instead of greater than
Good
or
job.
equal to something, it's gonna be less than or equal to something. Because it has to
Maybe you
be
don't-
smaller
You
than
want a
4.
cookie?
So that's what changes when it goes upside down. The range.
I don't have
Not
enough.
the x.
I don't have enough space for